So I just grabbed some page speed benchmark data from our public benchmark, and I wanted to look into this specific site, which saw a big jump in time to interactive and first CPU idle, which was the same in this case. So the first thing you'll notice is when I hover along the graphs, we've now removed that hover that used to be there, and when you click in, you can actually get the information for that test. We've got a new option there that says bookmark test. I'm going to go ahead and bookmark this before period. I'm going to take out the default and just call this before. And I'm going to click on the high data point for time to interactive, bookmark this test, call this after. Now, what you don't know yet is that we've just added 2 new bookmarks to the page that you can get to and look at anytime you wish. So if you scroll to the top of any of the dashboards, you'll see this new bookmark icon. When I click on that, you can see the 2 tests that I've actually added for this group that I want to compare. When I select on these, I simply say compare tests, and it's going to take me to a brand new compare dashboard. What's really cool about this is we've got the ability to look at visual differences, film strip differences, 2 new event waterfalls that show the major events and when they occurred, lined with that scrubber at the top of what you're seeing there in the film strip, and also showing deltas between the measurements below. So in this case, we saw an increase in time to interactive, and that's the one that we wanted to look into. Scrolling down, you can see we're also comparing the 2 different timelines here for activity. And you can see a lot of activity firing here on that second test, which we're going to investigate a little bit, driving out that first CPU idle. Here, if you had performance budget sets, you would see the delta between the 2 performance budgets. We'll show you that in our second example. And then popular metrics, as well as a breakdown across the metrics. So before I get too far, with this case, not a huge difference there visually that we're seeing. Maybe some banners are changing a little bit, and a little bit of a diff here when we're looking at the comparison of the visual image behind it based on the placement of these buttons. Anyway, not what we're interested in, not what we're looking for. Same thing on the event timeline. Things are lining up pretty evenly when we look at start render, speed index. It's when we jump out here to that time to interactive and first CPU idle that we're seeing that difference. So page is still rendering, page is still ready to use from a user's perspective, but when they try to interact with it, they're going to have a little more difficult time, potentially see things like jank when they're trying to scroll, or driving things like excessive clicks on the page to get to a navigation or add a cart or something like that. So a lot of issues happening there that we've introduced in terms of interactivity, and that's identified by those waterfalls we saw with the events there. If we scroll down, again, popular metrics, we see a big jump in long tasks. Long tasks are the things that are going to drive out CPU, first CPU idle, as well as time to interactive. And this is essentially where that main thread is just busy doing other things, executing JavaScript, and can't do anything else to render the page or interact with the page. So that was the biggest jump that we saw, and of course what we saw indicated by first CPU idle in our initial investigation. If we start scrolling down here, you can see that we can actually sort some of these metrics by different filters that we've put in here. So blocking time, JS and CPU, I'm going to go ahead and click on that. Again, we see our time to interactive. We see the number of long tests up from 5 up to 35. So we've introduced a lot more long tests in this newer version. And scrolling down, we can start to see what are the common requests. So this is really cool. We see that, hey, there's some common requests here. If we look at long tasks, that's what we're investigating. I can see, hey, look, here's this JavaScript that was on the page before, and it was executing 182 milliseconds of long task time, which is not great, but not end of the world. When we compare it now, it's taking roughly over 1,000 milliseconds in terms of JavaScript execution. So this specific request that we're seeing here seems to be the culprit that's behind a lot of that increase that we've seen. Additionally, when we want to look at unique metrics, metrics that aren't in both of the different tests that we're looking at, you can see that before, we saw some of these requests in here after we've seen these different requests, but they don't quite match up. If we look at the long tasks, hey, we've got some of these resources in here, but it's taking 0 milliseconds really for them to execute. Similar resources with a similar format, but that don't match up exactly, have been introduced, and we see 4 there that have introduced about 800 milliseconds each to our long task time. Again, just to kind of confirm, we've got that visual rendering here in the video that we can show you, and from that perspective, from a fully loaded perspective, no real difference. And then a comparison between the two test scenarios to see if there's any major differences between the methodology that was used in these tests. So since we don't see any visual rendering issues, we see JavaScript execution issues, we really kind of want to look into that, we've identified what the causal script seems to be, as well as some additional requests that are being added that are adding a lot of time. So we can actually go in and jump in and look at the test itself. And here, what we're seeing, if we open up the waterfall, is that we've got 1.3 milliseconds attributed to an unrecognized third party. So if we see the one that's got all the red in it, and we've talked about how to go ahead and troubleshoot this before, and we click on that URL, we can see that it was the problematic URL that was in the compare dashboard that we saw before, and it's introduced quite a bit of time. So here's the specific request, where it's coming from, how that actually manifests in the waterfall. So what I would do at a minimum is set a request group for this for the potential third-party issue, knowing that it's in an unrecognized group, so I could track that over time, set a budget on it, make sure that we're working to actually improve that and make that faster. As I scroll down further, I can see some other requests that are coming that are basically just requests that are coming from the main domain, but have a lot of associated execution time. And these are those new requests that we saw on the compare dashboard that look like they are adding a lot of time to first CPU idle. Looking at it, it looks like it was actually loaded by that first script that we saw. So this whole request chain has kind of been identified as the problematic issue that we want to look at and triage. So now you've actually gotten to what's the root cause and what's happening here in terms of what's causing this extra execution that you can look at. So knowing that, I would create the request group for all of these, throw them in one request group for a triage that I might be investigating in terms of long task time. Since they are from both a third party and a first party domain, you can still mix those two and create a custom request group, so it's going to be ultra specific about this use case that we saw. Anyway, hope that's helpful. I'm going to get on with another example to show you some other uses of the compare dashboard.